Okay, good morning, everyone. Thanks for joining this week's guest speaker series call. I think we have a really fun call today. It's kind of a combination of the probabilistic messaging working group and the modernized forecast process working group getting together and kind of combining since our efforts are so intertwined. We'll start off today with a discussion on what tools are available and that sort of thing at your disposal for probabilistic messaging, led by Phil Schumacher, Kelly Sayre, Jerry Wiedenfeld, and Mike Powell. And then we're going to move into a live, and then there'll be a Q&A after that. If you have any questions about problem messaging, they'll kind of have a little panel discussion available to answer your questions. And then we're going to move into a live weather briefing, which is going to be really fun, to try to go through the modernized forecast process. As you all know, we came out with the new AFD supplement there at the end of September. We've been talking a lot about the modernized forecast process, where we're looking for messaging opportunities, looking at ensemble and probabilistic tools. Andy Just is going to lead us to a weather discussion, looking at these tools, and we're going to kind of have a discussion. You can get involved, ask questions, ask to see certain things, share your commentary on what your interpretation of the data that Andy shows is. And in the meantime, during that, we're going to have a group of us working on an AFD content, key messages, and then some AFD discussion snippets based on what Andy shows in the ensemble and probabilistic tools. And then finally, we'll come full circle at the end and get into some messaging discussion with the prob messaging group. So it should be a lot of fun. Please share your comments and insights as we go through the call today. And with that, I will turn it over to Phil and the prob messaging group to get us going.
Okay, thank you, Randy. Can you hear me?
Looks good.
Okay, great. While the jet goes overhead, I will get going. Well, first, thanks everyone for attending today. This is just going to be a brief overview of probabilistic messaging, the tools that we have available, as Randy said, and some of the overall concepts that we've done over the last 3 or 4 years, and also give you some insight into some of the training that's available, especially if you haven't gone through this process before. So I'm going to first of all talk about the importance of using probabilistic information with our partners, and that is partially based on, or in large part based on, a survey that our group did in conjunction with all the Central Regions WCMs, and just share a couple of results here, hopefully to whet your appetite, so you can listen to Kelly Sayre and Peter Rogers' talk that was given about 2 months ago, and then we'll show you some of the probabilistic information we can share. We're beginning to expand that universe beyond snow to other parameters that I think are very exciting. And then we'll go through the messaging funnel. I think a lot of you have heard about it. You saw Randy talk about a little bit with the modernized forecast process as well during the fall symposium. So there's kind of, as he said, there's a lot of linkages going on here. And finally, we'll end with how we create these images. How do you get those images that you need to message to our partners? And then you'll have time to ask us some questions. So as I said, back in the late spring and early summer of 2022, we worked with the Central Region WCMs to send a survey out to all Central Region core partners. We got replies from over 2,500 partners. So this is probably one of the biggest surveys that I am aware of partners and their understanding of probabilistic information and what their needs are in general. We did go a little bit beyond that, just to understand what they're looking for, what they need, as they try and make decisions that impact people. So some of the things that we found out is that there's a lot of opportunity yet for us to build relationships. We have great relationships with our EMs, but what we found is that other core partners like DOTs and schools, they're a little bit more reluctant to call WFOs, and that seemed to be consistent across the region. So there's a lot of opportunity there for us to work with other core partner groups that are using our information to make decisions, to make them more comfortable reaching out to us to get that enhanced decision support services that we can provide them in real time as they make decisions that, in fact, a large number of people, not just during the winter, but any time of year. We also found out that partners have a lot of tolerance for information, especially probabilistic information. And a lot of that is based on timing, on how far out from the storm it is, how much they're aware of how much uncertainty there is as well. And so, as you'll see in a little bit, we can use this information to help guide what kind of messages we deliver to our partners as we move forward. We also found partners are very much looking for timing information. That's the great news. The bad news is we don't have very good ways to display timing information. I think most of us are aware of the onset graphic and ending graphic. Those are timing graphics, they're not always pleasing to the eye, I guess is the best way to say it. So we really need to work on, and one of our goals as a group is to work on better ways to display timing information. I know a lot of offices, ours included here in Sioux Falls, we use the Duluth timing graphic, but that's still very deterministic. And so the other thing we need to look at is how can we get probabilistic timing? Like what's the earliest snow could arrive at a location, or the latest time, or what's the probability of snow reaching an area by evening rush hour or morning rush hour? These are things that partners could really use that currently we really don't have a way to do, but they are looking for that information. Then there were three other findings that have a lot of caveats with them. And the reason is that we asked this, our questions were fairly narrow in some ways to try and elicit a response that we could understand. But as such, we're not sure how broadly those results expand beyond the question themselves. So one thing we found is for the question we asked is that partners are comfortable with large snowfall ranges. And they do look at the upper snowfall bounds in those ranges when they make decisions and understand that that is sort of a worst case scenario. But what we don't know is how tolerant they are as time gets closer or as you cross different thresholds. Like, does it matter if the lower bound were 0 instead of 3 inches, which is what was in our question? So we know that they are comfortable with it in some circumstances, but we don't know how far that extends. And that's something we hope to find out later. We also found out that they really like probability of exceedance graphics. They understand them, the graphic themselves, but we also found that they may not have a deep understanding of that graphic. And that may be, some numeric uncomfortability with statistics. But for instance, they can look at a graphic and understand what 50% chance of greater than 2 inches of snow is and where the probabilities are higher or lower from looking at that graphic in an aerial sense. But they may not be quite as comfortable looking at in extrapolating from that. Like, that is the probability of 1 inch of snow higher or lower, or 3 inches of snow higher or lower. We found that they were very uncomfortable doing that process. So there may be limitations to probability of exceedance in terms of trying to extrapolate from what is shown to them, but they're still found useful and they really do like those graphics. And finally, and this has been seen in multiple studies, not just in our survey, but there is a difference in how people react to probabilities and their tolerance for probabilities and ranges based on whether you provide them qualitative expressions of probability or quantitative expressions of probability. When the expression is quantitative, their tolerance tends to increase in our case for the example that we used. Unfortunately, that wasn't a quite one-to-one example. So, we can only say broadly that it looks like they prefer quantitative expressions, which again fits other talks that have been given both in the guest speaker series. We had one from OU this past summer and also in the literature as well. So this is kind of just a brief overview. As I said, Peter Rogers and Kelly Sir gave a talk back in October 1st. It's also available through the CLC on the whole survey, the different results and what they looked at. And I really encourage you to take a look at it to better understand where our partners are at, what they understand, and what we can do to help them. So then what data can we message? Well, I think we're all familiar with the snowfall information, right? We have the winter page with probabilistic snowfall. So you can do probability of exceedance, percentile snowfall, probability of snowfall ranges, the 25th to 75th, the 10th to 90th. Those are all there available for you to use. And they're very common to use during the winter situation. We saw Pleasant Hill use that this past, the ranges, we saw them use this past weekend, Thanksgiving weekend. Topeka is using probability of exceeding a trace right now for the upcoming winter event. So, we've seen this data before, and I think that gives us more comfort with it. But there's a lot more information out there. Thanks to Jerry Wiedenfeld, who's put a ton of effort into creating a lot of new tools that we hope to encourage all of you to use as we move forward, not just during the winter, but into the warm season as well. So one is temperature information. You can do probability of exceedance for temperatures, such as the probability of being 32 degrees or higher or 32 degrees or lower. And why would you do that? Well, the big reason would be if you're expecting freezing precipitation potentially. You can show in a different way the probability that liquid precip will freeze on contact in different areas, and help explain why maybe you have a winter storm watch instead of an ice storm warning to partners. You can also do probability-based ranges. So if say you're rather than a single number, so say like your high is 35 degrees, but the range is 31 to 36. The 35 would convey that there would be no chance for below freezing or, freezing rain, for instance. But the 31 to 36 would give you partners information that says, well, most of the range is above freezing. There is that chance that it could be below freezing. So those are ways you can use temperature information to help enhance your messaging. Wind information is also available as well. You can do graphs of like the probability of exceeding different thresholds of winds, one being 35 miles an hour if you're worried about blizzards, or 45 miles an hour if you're worried about like high profile vehicles driving on the interstate across central Kansas or central Nebraska. So these are also available to help enhance your messaging if you want to talk about whether it's blizzards or hazards to high profile vehicles when traveling. And finally, you can also do precipitation type. We all know this is part of the forecast builder that Andy and others have put together. And we can take that information and develop messaging for it. For instance, here we use points to describe the transition from snow to freezing drizzle in points of the Sioux Falls CWA. So this is another way to try and show the transition, in this case, a gradual transition from snow to freezing rain, or freezing drizzle in this case, and something that you can do later on. And we may see examples of that a little bit later. So this is all these tools, graphics are available to use beyond the snowfall that we have made available. Then we go to the messaging funnel, and this is going to be, again, pretty brief, but we've created this funnel. It was actually in conjunction with Tommy Grafenauer, who's part of the modernized forecast group or team, and we came up and we took what he gave and created it for messaging. And basically, it's based much more on forecaster confidence. And there's 4 stages. Just briefly, there's an outlook stage, which is kind of where you're like, yeah, there's a storm that could hit the northern plains or central plains, but not sure it's really going to hit my CWA yet. But there's enough that I at least want to mention it once or twice. Then you have the continued outlook stage where your confidence is increased. Ensembles are showing that there is a pretty decent chance that at least you're going to be impacted within your forecast area, but the degree of those impacts remain very uncertain. Will it be an inch of snow, or will it be 6 inches of snow, or freezing rain, or whatever? Then as your confidence continues to increase, you go to the watch stage. And at that point, you're pretty confident your area is going to be impacted. And you have some confidence in the location, although it's probably not down to the, like what counties yet. So like maybe the southern half of the CWA may get heavy snow and the northern half wouldn't, for instance. And then finally, you hit the warning stage where you're at your highest confidence. You generally have the areas figured out, what the impacts are going to be, and the timing's going to be. Be aware there's still uncertainty there. Like, when is the heaviest snow going to fall, for instance, at 1 inch per hour snowfall? Or when is that transition from freezing rain to snow going to actually occur? So even though we're at a more deterministic level, there's still some uncertainty and still some probabilistic information you may still be sharing with partners at this point. The key is with the messaging funnel is timing is less important than your confidence as a forecaster. And your confidence is determined by a lot of things, whether it is your experience, ensemble information, etc. And based on that, you can be in the warning phase 2 days before a storm hits when it's a big Colorado low coming out. Or you may still be in the watch phase 12 hours before a storm hits when it's a narrow band of snow. So it all comes down to your read of your analysis of the situation by looking at ensembles and other information that is available. And we found in our survey that the messaging funnel really aligned with our partner needs. And so we didn't ask them by confidence level what they were looking for, but we asked them by time. And what we found is, in general, when you get out to 2 days or more, the first thing they're asking is basically, am I going to get snow? Because if they're not going to get snow, they don't really care about the rest of the message. They're out at that point. And so you can see location shows up at the top. And then gradually, as you get, if they know there's going to be snow, then they might start worrying about amounts. Like how much snow might we get? Is it going to really be impactful? Am I going to have to cancel school, or am I going to have to do overtime for plows or whatever, or set up shelters? As we get closer in within 2 days, then timing information starts becoming more important. Initially, the starting time is the big thing because they're wondering when the snow will start, when they need to have people in, or if they can do morning school and then cancel early or whatever. And then gradually the end time gradually becomes more important as you get later in, because they're trying to figure out, especially for transportation officials, when road closures might be able to end. And you can see that end time is really important, and timing continues to be really important, less than 12 hours. And another thing that's important, although it doesn't show up in here, is snowfall rates. And that's really for transportation officials, especially they want to know when the heaviest snow is going to fall in terms of impacting their operations. But one thing you can see here, and this gets back to building partnerships or reaching out more to all our core partners, is that different officials have different needs at different times. Transportation officials have bigger needs than school officials at times. And when you look at the survey, and Kelly and Peter did a great job doing it, they discuss those differences and how it may impact your messaging as you go forward. So we have a lot of messaging on the a lot of training on the messaging funnel on the CLC. The first, if you haven't been exposed to it before, we did scenario-based training back in 2020 for the forecasters from our office here in Sioux Falls. Worked with our team to put together scenario-based training, which is like a Colorado low, a banded snowfall event, mixed precipitation, and Arctic cold, and looked at how the messaging trend progressed from the outlook phase to the warnings phase. Once you go through that, then this past fall, Dan Baumgart, Mike Fowle, and I took the partner survey results and updated what has changed based on these results and how we deliver our messaging at each phase of the messaging funnel. And so I really encourage you to look at both of those. If you have not been exposed to it, really start with the scenario based first, because it'll make the second part make a lot more sense. If you've done the forecast funnel before, the information that Mike, Dan, and I put together will really help you see how you can apply the messaging funnel to your messaging this winter and beyond. Finally, you have to have tools to create these. We show all these great graphics. So how do you create them all? Well, we have updated all the probabilistic messaging tools for 2023, 2024. And when I say we, I really mean Jerry Wiedenfeld has updated all of them, because he's our tech guru, and he's rewritten a lot of the programs, made them a little more easier to use. They're not huge changes from what we used before. But he did make it easier to find in the populate menu in GFE. All our tools now start with PM underscore for prob messaging. And so, for instance, PM underscore create storm images will create a lot of the snowfall images that I showed earlier. Currently, we have training on the CLC called probabilistic messaging tools. That was made in 2021. But the great news is John Gagan and Jerry have updated all of this messaging training, or tool training, and that will be available around December 1st. They're just putting final touches on it as we speak today, and it will be available for December 1st. And for anyone who hasn't used those tools much or wants a refresh, that training would be a great place to go to learn how to use those tools in your operations. And I should say, use those tools when there's no snow, just to see where the data goes, what it looks like. So that way, when the snowfall does occur, you aren't struggling to understand what the tools are trying to show or create. That gets us to the end. Again, I want to thank everybody on the team here, Kevin Deitch, Julie Demuth, Mike Fowle, Randy, Andy, Kelly, and Jerry. As Randy said, 4 of us are here today. So we want to take this opportunity first to show you what we all have available, but then also to allow you to ask us questions about probabilistic messaging, whether it's the tools to application and at this time, and we'd be happy to answer those questions right now. Thank you.
Great. Thanks, Phil. Excellent presentation. Really like the emphasis on going beyond snow. The tools that you describe and the prob exceedance graphics and that sort of thing are very valuable for other hazards, obviously beyond snow. So any questions for Phil or the group? One thing that came in while you were presenting, Phil, was a question from Joe Moore up in Duluth about whether these tools were installed, and Jerry indicated that every Central Region WFO should have all of these installed already. So I don't know if Phil or you or Jerry want to describe a little bit about where to find those in GFE perhaps.
I can start, and then Jerry, you can follow up if I miss something. So basically, once the tools are installed, they all will reside under the populate menu in GFE. And if your tools should all be in alphabetical order, so they all start with PM underscore. And I didn't count them up before I got in here. I believe there's 5 or 6 different tools, Jerry could correct me if I'm wrong, that are under that PM underscore prob messaging tool group. So made it hopefully very easy to find for all of you in your grids. You don't have to search through the menu to find different tools that are accessible. I don't know if you have anything to add, Jerry.
I just did a quick count, and it's 8 total tools. No, I mean, if anybody ever has questions about the tools, I'm here to, help with anything. I did just share in the text over here a bunch of examples that you could create with some of these tools. Sometimes, it's not necessarily evident what all you can create with these tools up front. So there's a lot of potential images that these tools can generate. I did want to say one thing. A lot of these tools are designed to put, you in the driver's seat. So they're not necessarily meant to just be running on cron necessarily, but to put you in the situational awareness and probabilistic messaging driver's seat. So you're going to be running through, getting an idea of what the probabilistic space looks like, and then from that, deciding what images need to be created. That was how a lot of these tools were designed. I mean, you can make, just a ton of images with these tools. You could really bring the CMS to its knees if you wanted to. So, be cognizant of what all you're wanting to create when you're going through this process.
Okay, thanks, Jerry. Thanks, Phil. There was a question, can other regions, WFOs in other regions install these tools?
Yes.
Yes. Go ahead, Jerry. You know about it more than I do.
Yeah, actually, right now, Western Region is going to be going through a lot of these tools. They have a few sites testing out a tech note I created for them. I've had a number of Southern Region sites go through it, and a few Eastern Region sites go through it. So yeah, they're all available. They're all on the software collaboration portal. I can share that link right after I get done chatting here. But yeah, they're all available for anybody that wants to install them.
Okay, thanks, guys. Another question came in. I said, are some WFOs using the extreme forecast index and shift of tails? I think these are very useful tools. Travis, I think we'll be talking about here very shortly when Andy does his weather briefing. I think we might want to circle back to that one. Any other questions or comments? You can raise your hand if you want to speak, or just type something in the chat. Okay, nothing seen. Thanks, Phil, for the briefing, and for your team for putting that together, and Jerry for your comments as well. So let's move on to the live weather briefing. I'm just going to set it up with a couple of slides, and then we'll let Andy take over for the weather briefing portion. Again, we want a lot of interaction if possible. Share your thoughts, your ideas, things that you utilize, how you're interpreting what Andy's showing, how that might impact your messaging and that sort of thing. So just going to kind of overview quickly what we're going to be doing here in the next half an hour or so. We've been talking a lot about this modernized forecast process recently, and really what we're trying to do is identify potential messaging opportunities looking at these ensemble and probabilistic tools. And then from there, you really want to assess the predictability and impact. So predictability, competence, however you want to phrase it. And then you're going to identify based on your the messaging opportunity, your confidence or predictability of the particular event. Then you're going to come up with a communication strategy and develop your message that is horizontally consistent amongst our products and services. And then you repeat this process basically as you go through the forecast process to determine your key messages and messaging strategies. So that's kind of the process that we're going to go through. Andy will look at some tools in ensemble output, and then we'll kind of discuss the predictability and confidence, and then we'll talk about messaging, how we talk about it in the AFD, what kind of graphics we might create. So that's kind of the overview of the modernized forecast process. And then, as you all know, we did an updated EFD or AFD supplement at the end of September. And the two of the main things in that were, one was key messages. We really want to leverage those. So that's a way to communicate the main points of the forecast and impactful information to our partners, the media and the public. These are short snippets, bite-sized summaries of the key things that you want to take away, or you want them to take away. And we're going to have those at the top of the AFD. and we're going to have like 2 people working on key messages as Andy does his weather briefing. And then going forward from there, one thing we found from past AFD surveys and that sort of thing is that the primary reasons that our partners read our AFDs are to better understand forecaster thinking behind the forecast, get a feel for forecast confidence or predictability, and to learn about alternate scenarios. And the last 2 there are directly tied into ensemble output and probabilistic tools and a probabilistic approach. So even though they're not saying they're asking for the probabilistic approach, that's when they say that they want to feel for forecaster confidence and predictability and learn about alternate scenarios. They're talking about ensemble output basically and probabilistic information. So then we're going to share some snippets again for an AFD based on Andy's discussion. And then at the very end, we're going to come back to what Phil and his group just presented on the messaging funnel approach. And one thing that Phil stressed there is that time to event occurrence is less important than forecaster confidence. Sometimes we can be very confident in our messaging for, say, like a heat wave in day 6 or 7 was a very predictable event. And other times our confidence is the predictability horizon for an event is much shorter. And so maybe our confidence isn't very high until it gets very close. And so rather than base our messaging on the distance or the time to the event, it should be based upon our confidence in the predictability of the event. So with that, this is kind of the process we're going to go through here over the next 30 minutes or so. I'll turn it over to Andy to give us a little weather briefing and go through some of these tools. And again, this is designed to be interactive. So if you want to chime in, raise your hand, or if you want to type something in the chat, I'll just kind of be looking for questions or comments in there to share with Andy as he goes through the briefing. So thanks, and take it away, Andy.
All right, thanks, Randy. So yeah, this is gonna be really fun. I'm gonna start off with where you can access several of the tools that we'll be displaying today off the CRH Google site for our science. We have an ensemble probabilistic guidance tool page there, and there's also a link in there to another guide to ensemble's probabilistic based guidance. Similar tools and all that is listed in there. It's just a little bit different layout, courtesy of the St. Louis office. So be sure to check this out. You can certainly bookmark this, and I will also put the link for this right in the chat right now. All right, so the first place that I like to start with everything when it comes to looking at messaging opportunities and all that is to figure out, especially when you're looking out a little farther out in the forecast, is the range of potential outcomes. And one of the nicest ways to get that is through cluster analysis. I am going to preface, so we're going to use the WPC website for the cluster analysis. There's also cluster analysis in DESI, but we're not going to touch on DESI with this presentation, just because we know that some offices don't have access to DESI. So we're going to start again right here with WPC's site. And so in this example, I'm just starting off here with day 3 and actually using the 12Z yesterday. And I'm particularly doing this because just if you're kind of like following the forecast over several days, one of the things that we're kind of following here from a CRH perspective is this system coming through near the Ohio Valley, Great Lakes, Central Plains region here for Thursday night and Friday. We have this, this trough and feature over the southwestern U.S. coming in. This is at, for 0Z Saturday, and this trough, and it hangs over eastern Canada. And so you can kind of envision this, that you have this subtropical jet coming through the southern plains into the Ohio Valley, combined with a polar jet crossing Ontario, the Great Lakes, and Quebec. Almost a situation here of a couple jet situation going on in the vicinity of the Ohio Valley and Great Lakes. If you look at this 4-panel again, this is day 3. Day 3 usually in this cluster analysis, and the cluster analysis is just based off the 500 millibar height pattern. There's typically not a lot of difference, but in some cases you'll see some. What is fun to do with this is to use the demodeled DT, and so we can kind of look at this time period. And the latest here is when the bar is to the right, and we're just going to look backwards in time to see, how have the ensemble data looked for this event going back, several cycles. We can look all the way back to when it was like a day 9 forecast, and then all the way back up forward to day 3. pretty much all of them. It's important to note that these clusters change. So I can't just look at cluster 1 as a D mile DT all the way through, like it's the same, like here's the euro today, euro tomorrow. That's not how the clusters work. The clusters here are just representing groups of similar solutions, and I'm not going to delve into the whole process on that due to time constraints, but you can kind of see what is making up each cluster as we go along. That's in the legend titles here, with the C, G, and E representing Canadian GFS and Euro ensembles respectively. But all of them again have this. It's been pretty similar cycle to cycle here with respect to where does that there's going to be a trough set up over the southwestern U.S. Maybe there's some slight differences in depth, little slight differences in the progression of it, maybe some a little farther east, a little farther west. But when we go up to at least the current, closer to the current forecast time, they're all pretty good agreement with the feature over the southwestern U.S. at this point. Let me hit my back button, and through here, I just looked at the 500 mile height. We're going to zoom in a little bit to the central U.S. and we're going to look at QPF. Through QPF, we do see some difference, even though that the 500 millibar height patterns are the same. There is some differences here in the QPF, and the shading represents differences from the mean. And so you have in like cluster 1, for example, which is heavily dominated by GFS members, you can see 97% of the GEFs have this farther northwest solution, noted by a heavier QPF in the green color shading, going all the way up into northern Missouri. Whereas, let's just take cluster 4. That's one of the drier scenarios for the northwestern edge of this system. And then clusters 2 and 3 are somewhere in between. Cluster 2 is more of your European ensemble. Cluster 3 is more your Canadian ensemble. It's important to know where these ensembles sit, because one of my second favorite product I love looking at is the Extreme Forecast Index. And the Extreme Forecast Index is purely based on the European. So given that what we see here in the cluster analysis, cluster 2 is again heavily dominated by the European ensemble, but you do have some Euro ensemble members spread out through clusters 1, 4, and 3. So if we jump over to the Extreme Forecast Index, and I've clicked on the QPF here for 0Z Saturday, no black contours, which represent the shift of tails, but you do see some higher EFI values stretching across from Missouri through northern Indiana in this time frame. So you may want to kind of dig into these areas, and the best way to do that is go to the ECMWF site, charts.ecmwf.int, and then go to the EFI CDF mediograms. And I will post that link here in chat just for everybody's reference. And so here's based off the 0ZZ. So you could do this in Weather Bell, and I'll show, like, I can do the Weather Bell equivalent too. But the ZFI CDF graphs are really neat. So here's St. Louis, which is in that heart of the highest EFI of QPF. And you can look, and it nicely shows previous cycles of the European ensemble all the way to the latest. Colors may not be the greatest for for color blindness, but I will note this lighter shade in blue dashed line is the oldest forecast. The red is your latest, and then the black is normal. But normal based on the model reforecasts of the past 20 years. And we see that each successive cycle has had more and more QPF. Now that more and more QPF could be a function of that you've increased certainty within the European ensembles instead of being super spread out, and now that they're coming more in line. It could be that the European models are now a little stronger with the wave enforcing signals, maybe a little bit more moisture content. Those will be all things you can dig into. But what you see here is that, again, overall, the entire European ensemble is increasing in the amount of QPF for at least this specific point at St. Louis. Having said all that, the curve still has a lot of spread. You can see that the lowest, it's unfortunately in metric, 15 millimeters, so it's about 0.3 or so of an inch at the 5th percentile, compared to the 95th percentile, which is suggesting closer to 40 millimeters, or getting up in that 1.2 inches area. So still quite a range of potential outcomes that's worth messaging in your AFD. So let's talk a little bit about that force and the ensemble situational awareness tables. While they represent ensemble means, they are just so perfect for giving you just a general quick idea of how do things represent, especially relative to what would be a normal for this time of year. And it uses the CFSR climatology in determining that. You can look at the naves, you can look at the European ensemble. Here I've just pulled up the European ensemble for precipitable water. And here we've got about 0.75 inches or so extending all the way up into Chicago's area at 12Z Friday. Be sure to check out SPC's Sound and Climatology page on this one, that you can look at various sites and see. Let me zoom in, and we can look at, let's say, Central Illinois for its precipitable water. You can do lots of different parameters. They recently updated this year, and we can go to about November 30th, December 1st or so here, and you can see 70 was that 0.75, 0.8 or so. You're looking at the 90th percentile, at least with respect to the climatological sound and data that that exists for ILX. It's noteworthy that from a return interval perspective, it's nothing out of the ordinary. All the heavier, relative to that, is centered more down over the Gulf. That's precipitable water. You can also check out the, in terms of atmospheric river signals. This is the IVT. And again, this is not anything out of the ordinary, but there is a signal that you're going to have an atmospheric river pulling moisture up out of the Gulf northward ahead of this wave. In the naves, one of the cool things that exists here is a model climate percentile relative for the GFS QPF, GEFS QPF. Now, again, remember from the cluster analysis, we saw that the GEFS QPF was the farthest northwest. Having said that, this at least gives us some context that you can put into, say, an AFD or any other messaging features that, hey, this small QPF for the 0Z Friday, 0Z Saturday time period, pretty high relative to this climatological period, which is October 15th to the 13th of January, centered again going into St. Louis's area in that. One may wonder, okay, we're getting all this rain, is this going to be a problem? So I was, from a hydro perspective, did take a look. So just off the waterweather.gov, we do see a lot of this general region is dry. In fact, some of the water levels are getting on the really low side here, normal to really low, because your deficits are running pretty high over this 30-day time frame. I did want to backtrack just a bit here. I mentioned about the EFI CDF. If you went into, and I wanted to pull this up, so in Weather Bell, if I went for St. Louis for that EFI, that EFI CDF. So this is the 24-hour QPF. So we'd particularly be looking at the box and whisker here for 0Z Saturday. In fact, this is the 6Z Euro. Let's go back to the 0Z Euro so that we're comparing apples to apples. And the range is anywhere from 0.4 there to 1.6. Kind of matches up pretty well, I think, with what I was mentioning there for the values. 25th to 75th, pretty stable there between pretty small range, 0.9 to 1.3. But again, there's overall the whole entire distribution has a lot of different outcomes that you can end up with this event. Another feature with this event is the function. Well, since I'm in the rainfall, let me do the let me talk other things with rainfall, and then I'll come to the winter side. I've been waiting for the HREF to come in because we can look at some cool things once it gets out farther to pull up like local probability match mean and all that. But just to maybe this is a good time to reinforce the synoptic pattern here, and that just in the HREF you have again a nice scenario for developing coupled jet situation going into later Thursday night into Friday as this one wave comes out of that western trough and comes into the Great Lakes region. If you've never looked at the machine learning progs, I mentioned all about the GEFS, QPF, and M climate. The machine learning progs also use the GEFS for this, and so this is the day 2. So one bummer part is that these are running 12Z to 12Z versus 0 to 0. But at least in this case, the machine learning progs do have a little bit of excessive rainfall concern going into Southwest Missouri. But again, we've had, we're running deficits from a 30-day perspective, and I think that's maybe one of the reasons why we're not seeing much for excessive rainfall coming out of this system. All right, let's talk a little bit about maybe from a winter side of this, because obviously you're sending this strong atmospheric river. Well, not strong, I shouldn't say strong. It's maybe more of a moderate, but coming up into a colder regime. So there's going to be concerns, whether or not you end with mixed precipitation stuff and all that. So the MBM has various different things to output, and we can look at. Let's start with just a P-type thing here first. We can do. Let's do freeze and rain for a start here, and recall that with the MBM with 4.1, these are all relative frequency and using dominant precipitation types coming out of the individual members, and there's some downscaling in that. So based on these probabilities here, there is some concern of some freeze and rain, which probably makes sense. We're getting a little warm air aloft feeding over over a low level cold dome. It's not for long. Makes sense. Diurnal heating and all that should take care of that threat during the afternoon hours, especially here that we're in just late November, early December timeframe. And then we could also look at the snow probs with this system not overly high. Come on, give me more. Oh, that's because I just need to do that. I need to do a double click. So again, it's relative frequency and all this. So it almost kind of it incorporates a little bit of the pop into here as well. It's not the unconditional that we had with or a conditional we had with 4.0. So there's definitely the threat, on the northern side of this precipitation shield of some snow on that. I was going to show some. Sorry to bounce a little bit here, but I was going to show some HEFS information, but given the fact that we don't really have a lot of concern here with respect to the whoops, sorry on that. If you just looked at obviously Mississippi's a long basin, in terms of long response for rain. I mean, not going to see much from this event there, and maybe if you take even us maybe a potential faster responding river here. Again, remember that the HEFS is working with the GEFS data. There is some higher probabilities there, but it's still everything's below any kind of concern for flooding. Again, that correlates with that excessive rainfall. Back to P-type, if you haven't looked at these, so this, again, on the ECMWF chart site, there's P-type mediograms. And from here, again, you can choose various different sites. I currently have Chicago on here, but if you looked at the P-type props from WSUP, let's go farther west, go to like Davenport versus, I had Chicago up, which was all rain, but Davenport here have a lot more mixed issues going on there. You can go in Des Moines area as well. Mike, got a good site since I think you're on.
Yeah, try Ottumwa, Andy. Ottumwa would be a good one.
Yeah, let's do it.
It's gonna look similar to what you had for Davenport, but that's a good one.
Oh, please tell me I spelled it right.
Yeah, that's correct. I don't know why it's
not showing up, and Ottumwa not
yeah,
showing
I had it
up.
up. Yeah, it's give it a second.
Yeah. Well, I could also do. Oh, there finally. There's Ottumwa. So it's interesting, like in this scenario, that you'll notice that what's really cool, and I'm going to comment on this. So look, if you look at Friday, so you've got chances for freezing rain, sleet, snow, and rain all in that color bar. But you'll also note that it's almost like 50% of that doesn't have any type at all, basically suggesting a dry forecast. And if you look at this, let me just go back to like the QPF here from. Well, I mean, the EFI kind of suggests that you've got this northern edge that has a sharper cutoff. GEF's mean QPF, you could kind of envision there's this sharp cutoff to the north, and it makes sense. You got a couple jet scenario. You're probably going to have drier air from the north, which we actually see in the PW. Look at this this minima here of like 1/4 of an inch just sitting just to the north. So you end up with both the jet circulation and likely an FGen zone on the northern edge of this wave as it comes to the northeast, bringing in that dry air to the south. So not only do you have, like, in this zone where you're going to be dealing with mixed precipitation, you're also dealing with a zone where there's question marks of, is the dry air going to totally infiltrate and remove the precipitation entirely? So I would say this area from somewhere in Topeka's area, northern Missouri, eastern Iowa, northern Illinois, southern Wisconsin, and even even going into lower Michigan, very problematic from a P-type perspective, and from, are you going to have precipitation at all? Let's see here. The only other final item I'll pull up here is WSSI. From a probabilistic, I just pulled up this is going to be utilized in a lot of your a lot of this other data, but anyway, just some minor impacts, and it seems reasonable based on what we've seen from at least the probabilities. If you do snow and ice, there's it's kind of interesting here going into the NBM itself for I don't want ice accumulation percentiles. I wanted this. So if you look at total, ice accumulation with this event, here's a couple hundreds from the deterministic point of view. Probabilistic, by the way, I'm going to show this because this is interesting. So the probabilistic versus the deterministic ice. You saw the deterministic ice was couple hundreds. Two things. One, the maxima area of the ice, deterministic ice, is actually farther south than the probabilistic. The probabilistic values here overall aren't that high. recall from like the eSteam WFP type diagram there from like that for like Davenport, they aren't that high for whether it's freeze and rain or sleet. You know, I know this should be more freeze and rain based, but just to that point. And I think that this all comes back to how the NBM creates deterministic versus probabilistic. Probabilistic is going to be more heavily weighted towards the Euro ensemble because it's an even weight situation, but the deterministic is going to have a little bit more CAM influence, and in this case, kind of like maybe like the NAM nest being ingested into this situation, as well as like the high res windows that maybe focus in a little bit more heavier precipitation or having a little more freeze and rain and icing going on that northern edge.
Hey, Andy.
Yeah.
I'll jump in. So Brian Bardenbrook asked a question. He said, is bias correction of QPF or temperatures playing a role in the deterministic versus probabilistic values?
So that in the NBM, we for both deterministic and probabilistic, while there is downscale and IRMA is not utilized in the P-type data. So I don't think it's as much there in the P-type. The QPF will have bias correction because QMD is used for the all the ensemble data sources, and and you'd have to look at, okay, well, we already saw that the past 30 days has been generally dry, and so if the NWP data has been suggesting precipitation and it's drying out, then your QPF or the QMD output would be lower. And we should actually show some of the probabilistic QPF in here, because I think that might shine some light on this as well. So here's the 24-hour QPF for this event probabilities, and at least just over a quarter inch are very low. And this actually makes sense. You know, we actually totally see, like, this is the, you know, almost like the frontalytic side of that FGen circulation, along with the you know, the jet circulation upper, you know, the couple jet circulation pulling in that dry air, creating a sharper gradient on that northwest side of the precip. And by the way, if you know, sorry on sidetrack, but here's the QPF probabilities for over an inch, thinking back down to the St. Louis and even going to the central Illinois situation. Go up higher, 2 inches, not overly high at this point for probabilities, but is there anything else anybody wanted to, any other comments? Anything you want me to pull up?
Yeah, if you have any thing that you want Andy to discuss or pull up, type in the chat or raise your hand if you want to talk about anything that he's discussed up to this point.
Yeah, that's an interesting comments there, Brian and Matt, about how QMD is. Yeah, like I say, like if you get into a dry, if you're in a dry period, and the model's been producing precipitation, particularly the ensemble data, the QMD is going to wipe that, is going to hold that in. It's, you know, for upcoming events until you know the NBM, I guess, is trying to be smart and saying, hey, NWP's been over forecasting, but then when you actually get into an event that hey, the NWP is actually telling you the right thing, that it will backfire a little. Those are good things to coordinate with WPC on with QPF. All right, we want to hear TJ's comment there about looking at, you know, certainly the messaging on this. So let's, we want to jump to the AFD and then we'll go to messaging.
Yeah, that sounds great, Andy. So what we've had going on here in the background as Andy's been doing his briefing is Dustin Jordan, Sean Jacobs, and Greg Heavener have been working on some key messaging and some AFD snippets. So I think Dustin is going to lead this portion of the conversation. So thanks, guys. Take it away.
Sounds good. Yeah, and thank you, Andy, for setting us up nicely. I was doing some quick work typing over here as Andy was discussing. So, feel free to make comments on my AFD. It's not going to be 100% perfect, but that's what these calls are for, is to talk about this and to discuss these things. So, I don't know. Did you want me to talk about key messages first there, Andy? Do you want me to do that first? That sounds good. These are kind of the three main key message points that we came up with during our discussion. Obviously, we talked about the widespread rainfall across the area. We talked about the low confidence on just where that heaviest axis may be, really honing in on the cluster analysis that Andy showed earlier, just kind of showing that could change, locations depending on what ensemble system you're looking at, and just kind of give a range of possibilities there too. So there's still some uncertainty there. And then also talking about the, low chance of some freezing precipitation kind of on the northern edge of this system, using some probabilities in there in our key messaging as well. And discussing too, just the general consensus on the presence of infiltrating dry air, confidence is low. So there's still some confidence issues, even with as you get on kind of the northern extent of that system. So those are kind of the key messages we came up with, and feel free to chime in on any key messages that you may have come up with them as we were discussing. I'd love to see other key messages. So if you want to chat those in there, feel free to do that. It'd be interesting to see what other key messages are there. So as far as the AFD portion goes, started off just talking about the upper level trough kind of ejecting out of the Four Corners region. Good seems to be pretty good consensus on that from the ensemble, deterministic, pretty good agreement there in general, at least with that happening. And then also discussing a little bit about the ample moisture pulling north, as Andy discussed, with us being close to 90th percentile for PWATS, discussing that, based on climatological input there. And then combining that with the coupled jet, obviously we see the potential for widespread precipitation. Discussed a little bit about the NBM showing a 90% chance of like a half an inch of rain over much of that area in a 24-hour period. So pretty good amount of rain, which when talking about it a little bit more, and I think I discussed this a little bit further down, but notable that what Andy brought up about the fact that it is going to be an area that hasn't seen a lot of rain. So this could be actually a good rainfall for much of that area too as well. But one of the things we did see is that you could see some of the ensemble systems, so notable difference in location and timing, kind of talking more about that cluster analysis. St. Louis, talking about the range of possibilities we saw there in the EPS, anywhere from 0.3 of an inch all the way up to over an inch of rainfall potential there. But you do see a pretty good range there of possible solutions. So that was something notable from Andy's discussion. Again, they're talking about a little bit about the deficit. We've seen not a lot of rainfall over the past month or so, and then talked a little bit about also the machine learning, noting that in there. Potential maybe for some stronger storms in southern Missouri anyway, as you lift warm air northward. And then getting a little bit into as well, talking about the potential for maybe some wintry precipitation on the northern periphery of that. But overall, low chances for that, but there's still the potential there. And talking about that, again, throwing in some probabilities of that too. So talking about it generally less than 20%, but still talking about it as a possibility and a potential there in that area. So again, this is a quick and dirty AFD from what we discussed. but feel free to chat or talk about it in the chat. Anything that you might have wanted to add, or maybe things that we missed during that discussion.
Thanks, Dustin. Awesome. So one thing that I think is really important there in your key messages is where you use the WEP terms like low, you put in a percentage behind them, which we know from social science is really important for adequate, proper interpretation, right, and effective communication. We have a comment from Kathy Zapotny. First key message, would like to see a number on what the heavier rainfall means, 1 inch plus, 1.5 inch plus, and give number for probabilities with that increasing confidence. You know, the 1/2 inch and 90% chance in the body of the AFD.
Yeah, that's a good point. Yeah, we could have definitely added something more in there, you know, on numbers and be more specific up there at the top too. Yeah, that's a great point. One thing I learned too, though, from I just did a IWT yesterday with partners. You know, as they're sharing this information, I think we also have to think about crafting our key messages so that it can be a force multiplier. You know, how much, you know, we obviously want to kind of limit jargon or kind of limit those things in our key messages. So just, you know, thinking about crafting our message towards what we want, you know, the public maybe to see from our partners, and especially when we're talking about EM sharing this and those kinds of things. So that's a great point.
Yeah, great. I agree. Great point, Kathy. Some other interesting comments coming in. Amanda mentioned maybe include a brief note of impacts from the heavier rain. I think is one of the key messages. That's a good one. And then TJ has a really interesting comment. You know, he says he appreciates the AFD example, but he has a philosophical question. Should there be any whys in the key message, such as the infiltration of dry air?
Yeah, that's a good question.
Yeah, I think my 2 cents, I would tend to agree with you on that, TJ, that maybe avoid the why and just here's the key message. The background can be in the body, maybe not in the key message. And there, Frank's had a really good comment earlier in the discussion about kind of really refining and going through your key message. You know, Dustin's and his group are kind of doing this real quick on the fly as Andy's talking, but you know, thinking about the things you just brought up, TJ, and Amanda and Kathy as well. All of the things that you brought up are very valid points that you'd want to refine as you try to focus in on your key messaging and make them succinct and clear. So I tend to agree with your comment there, TJ.
Yeah, that's a great point. That's a great point. Yeah, it just kind of shows you that, you know, I think this is where, you know, these key messages will be, you know, a whole operations concept, right? You know, when you're in operations, we're all going to be talking about this and crafting this with, you know, everybody in operations. So that's an excellent point.
Yeah, I was just gonna say, like, these are good ones the key messages. Share them around your staff. You know, do they hit all the marks that you want to make sure that you're conveying to your partners and they're conveying on to public and others. By the way, did want to switch tabs here since the HREF did come in, and I thought this was interesting. You know, local probably matched me, and I won't go into all the details on it, but let me go to the sector so we kind of zoom in. The local probably matched me, and if you just take that right off for their St. Louis with 1.5 inches or so, which is on the upper end of the EFI CDF there from the European ensemble. So, you know, with a little, you can kind of tell there's a little bit of convective elements mixed in, aiding in that. And then certainly, again, that tight gradient to the QPF on the northwest side that we've already kind of discussed a lot. So.
Yeah, good thought there from John too in the messaging. You know, you can always kind of use your key messaging and then talk about your why. That's a great point, John.
Yeah, I really like that concept, John. Well, this is excellent. Thank you, Dustin. Great discussion, everyone. Really appreciate the interaction. So let's move on now. Oh, go ahead.
Yeah, I was gonna skip. Nice segment. Thanks, Randy. Yeah, I was just gonna move on to the final item. Yeah.
Yeah, so let's go ahead and transition to the problem messaging group, and any comments that you might have based on the discussion and the stuff that the content that Dustin and the group put together for the AFD. What kind of messaging strategies might we take for this event?
So with this, I want to bring in Jerry. He's been grabbing a couple of screenshots here even this morning on this event. So yeah, Jerry, you want to take it away on some of the things that you have here that you share with me?
Yeah, I mean, I reached out to a few ITOs, counterparts of mine, at some offices, so Des Moines and ILX and Chicago and Indy, and just try to get a few images, just that I thought would sort of summarize some of what we were seeing. So it's nothing all that huge here, just some really examples of some images that you could potentially use. So the first one here is that potential low. So that's using the min-t, and the code that was used to create that was populate max min-t probs. And just a real quick synopsis of how that runs. So what that's doing is it's taking the MDM percentiles as well as the standard deviation information. And from that, it redefines the CDF using a binormal distribution and the official as the mode. And so your forecast is very important into what this is actually doing. And so it will redefine the CDF, and then you can get the, whatever exceedance value you desire. Here we chose lower than 32, just to sort of get an idea of where we might be seeing some of those freezing surface temperatures overnight. And then the next image sort of over to the right is the actual hourly temperatures there at Rockford. Now, this one's a little bit different in that there isn't hourly information from the MBM. There is an hourly probabilistic information from the MBM in GFE. So I had to sort of create my own distribution here using the models from within GFE. So all the bias corrected models, all of the raw models go in here. So this one's going to be a lot better if it's closer in and more, you have a lot more models that you can work with in the short time ranges. But you can certainly get an idea, and it looks, in this situation where the temperatures are going to be less than that, 32 and getting down below freezing overnight. And then the last one there, that's using the probability of the pod images or graph data from what you get in Forecast Builder. And so it starts with the MBM. And so again, this is very much attuned to what you are doing through the Forecast Builder process. So then if you want to just go to the next slide there, this is something I had ILX quick generate. So that's sort of the same idea as what that station-based graphic was, but this is a graphical representation of that over the entire state of Illinois. And so this is using all those pot, conditional pots that we have.
Yeah, so some of these might be perfect for like a, maybe on a webinar or something where you may be trying to convey how things might evolve, timing, and things like that.
Right. And this one was actually using create loops, which is sort of outside the prob messaging suite. But so I created a loop using all the graphics there, and then actually stitched them together to do the quad graphic that we see there. This was one that I'm hoping we can get more showtime with in this year's prob messaging suite.
All right.
Hey, thanks, Jerry. Any comments, questions, or ideas on the messaging aspect? Other thoughts?
Randy, this is Phil. I was just going to say too, if you're down in Southern Illinois or by St. Louis or into Indiana where it's all rain, and I saw Indy was actually already doing this. I mean, probability of exceedance for QPF is also very doable. It's something I didn't really discuss in my talk, but I that would be something I would focus on, especially if you're kind of in a drought, like it seems like St. Louis was, at least looking at the chat. People might be really interested in getting that inch and a half of rain to start alleviating the dry conditions and stuff like that as well.
Yeah, great point, Phil. And that was one of the things that came out from the probabilistic messaging survey that Phil discussed earlier, is that the vast majority of the partners really liked the prob exceedance graphics and did not have a hard time interpreting them. So it's a really valuable tool for us to utilize. And Phil, maybe could you talk a little bit about whether it's QPF or snowfall, about when to use ranges versus prob exceedance based on your confidence a little bit? What's the prob messaging team's thoughts on that?
Yeah, sure. Basically, we kind of our way of approaching it is that once you get into that 30 to 50% confidence range, especially as you're approaching 50, that's when you can start using prob exceedance. You probably don't want to start advertising specific snowfall ranges yet, because your confidence is pretty low. There might be a lot of variance yet, or high standard deviation in QPF for snowfall. But kind of setting that table for like the probability of exceeding 2 inches might be one, or your partners may let you know when you talk to them what values are critical. 6 inches is another, or 4 or 1. Can really help you kind of drive the message that here's your chance for seeing some snow or some really snow that may really grind travel to a halt. And then as your confidence starts increasing over 50%, especially as you start approaching, towards closer to 80, that's when you start using those ranges to really help you out. So once you're in that watch area, especially higher in, then you kind of start using ranges to highlight what your snowfall chances or amounts might be. A lot of times we use the 25th to 75th. Here I think that's been fairly common across the region. And we'll show that to kind of show both the low end and the high end, and then we'll actually highlight that graphic too. I think Mike in the chat talked a lot about context, and so did Kelly, and try and highlight the area where maybe that you have unusually large ranges, and we'll highlight that in there with like some sort of circle graphic, and just say, hey, there's this is the pretty uncertain here. If this band goes farther north, you could end up with more snow, etc. To kind of, so that we're not letting people try to guess why it's 1 to 7 inches in Brookings, South Dakota, or Minneapolis, or something like that. We try and explain that we're aware of that uncertainty, and it's because of where that location may vary a little bit. So that's kind of how. And when you get into the warning phase, then you might be solely using probability ranges. Although there are times you may want to still use a probability of exceedance even at the warning stage. If like you have a key partner like a DOT, maybe 2 inches is a threshold for them on whether they plow or not. And so you might want to include that like in a DSS packet to your DOT saying, hey, here's your probability of 2 inches across the area. You might have to plow like in north of Mount Pleasant if you're in Michigan, and not worry about it quite so much, or the probability is much lower, farther to the south of Mount Pleasant, for instance. So although you tend to use ranges more as you get higher and higher confidence, there's still a place for that probability of exceedance for specific partner needs.
Excellent. Thanks, Phil. Have a good discussion going on probability of exceedance graphics in the chat. Kelly, I'm going to put you on the spot a little bit. You talked a little bit about the survey results and how people, what they can and cannot deduce. Maybe you can expand on that with some comments.
Sure. One thing we found is there is some inability for partners to deduce information from a probability of exceedance map if it's not showed. So if you go back to the survey, we had showed them a map of the chance of getting 2 inches of snow and the chance of getting 4 inches of snow. And so they could see that and they could read those maps correctly. But if we asked them what the potential for 1 inch of snow was, so they should be able to deduce that, knowing, the probability of 2 inches of snow, you should be able to know that it is some percentage greater than your 2 inches. But they weren't able to do that. In fact, half of them weren't able to infer that information. So lots of discussions with our social scientists at NCAR about what this means and what we can do about it. And we don't know the answer definitively. We'd have to ask more questions, but certainly keep thresholds in mind. If you can show multiple thresholds, do that, or point them to like our winter prob snow pages where you can pick your own threshold and be able to get that information instead of having to deduce it themselves.
Excellent. Thank you for that clarification, Kelly. Really important information and really, really interesting. We have a lot to learn, right? And it's kind of come up. We don't have all the answers. Obviously, we're going very confident in the direction we're going, and we know we're going the right direction. But I always compare it to IDSS. You know, we started it a long time ago, 15 plus years ago, and we're still learning and still improving. And that's how it's going to be with the probabilistic tools and communication products and services going forward. So other comments, questions, or anything that somebody wants to raise that we haven't discussed? Go ahead, Mike.
Hey, I just wanted to make a quick comment here, and Andy did a really nice job talking about the potential for at least a light wintry mix of precip here across Iowa. And one of the challenges I know that's still out there is, you know, how do we message scenarios where it's a low confidence forecast, but the potential for impact is pretty high? And how do we do that succinctly? How do we do that where it's very digestible to the partners? So I think Jerry showed in his couple examples there that I think we have some ways to show some probabilities in terms of what is the p-type going to be in terms of point data. There's the Duluth matrix. Yeah, there's the point data that's there. But one of the challenges we found, and I think there still needs to be worked on, is how do we show some of the spatial context of that? And I wanted to do just a quick shout out for, and it was talked about in the symposium as well, that Josh Caspin presented on the WSSI. And that's one of the tools I think that's really gonna, and yeah, Andy showed it earlier. So again, if you're trying to look for the spatial extent of, say, a light wintry mix, I mean, what options do we have right now? It's pretty limited. And I think this is probably one of the better ways to do that. Obviously, the challenge with this, especially with the WYSI-P that they're calling it, is that it's experimental right now. Now that's supposed to go operational very soon. And maybe Randy or Andy, you guys might have an idea. I know Josh talked about that at the seminar. But we're also working on, as part of the prop messaging team, trying to find a way to kind of standardize these graphic productions, so you're not having to do necessarily a using Snagit or whatever your favorite snipping tool is to try to grab these images. And we're doing that a little bit with the days 4 to 7, greater than a quarter inch of snow and ice. I think the goal down the road will be to do this also with things like the WYSI-P to make these graphical display a little better, because otherwise, like Andy's doing, that's kind of your option right now. And so there's still some work to be done there. And but I do want to throw a shout out. I think the WYSI-P here is going to be one of those graphics that's going to be very useful for those low confidence scenarios where you're just trying to show, hey, it's low confidence, but if something happens, it could be bad. As we all know in Central Region, a little bit of ice, and Brian in Omaha can reference this as well. A little bit of ice can cause a lot of havoc on the roadways. So, you know, it doesn't take a whole lot. So I just wanted to throw those kind of ideas out there that, you know, there's still work to be done, but I think there's some new innovations that are coming, whether it's via DESI or WPC, that are going to be pretty handy. So I just wanted to throw that out there. Thanks.
Thanks, Mike. Excellent comments. And Chad Hahn put in the chat that WYSI-P is operational on December 15th. Okay, any other comments, questions, or items that anybody wants to raise?
For something fun, I did put up the Fram mean there, the HRF ice 24-hour ice acumen in 12Z Friday, a little higher there in southeast Iowa. But again, it's a mean, you know, so you got to take that for what it's worth.
Yes, thanks, Andy. Well, I think we're an hour and 20 minutes. It's been really fun, a great discussion. I appreciate everybody's comments in the chat and folks that have chimed in with their thoughts. It's been really awesome. I think these are super fun because nobody knows the answer. We're just jumping into a real-time event and kind of, walking the tightrope without a net. So they're really fun. I hope everyone enjoyed it. We had awesome turnout today. We're going to try to do this like once a month going forward. We've done some of these in the past and we've had really good feedback. And, as we're kind of emphasizing the modernized forecast process and how to tie our confidence to messaging, we're going to really focus on trying to do one of these like once a month. We'll just put them on the guest speaker schedule. We'll do some publicity, let you know when they're going to be and that sort of thing. And hopefully you can join and participate in another one soon. So thanks everyone for joining today. It's been a really good session. Appreciate it. Have a great Wednesday.